And we're live! I caught myself off guard. Welcome to RockSim Live. I'm Tim Van Milligan. I'm the host. We are back. Last week I was out of town, and it is good to be back. I have the chat going, and so this is where you can ask your questions about RockSim, RockSim Live, RockSim Pro, or the Launch Visualizer. So yeah, it's good to see that a number of people already here. It was kind of a last minute scheduling thing, but there are people here. There's a bunch of people. So we have Carlos K from Marietta, Georgia, and he says it's hot and muggy. And Chris's Rocketry and More from Golden Valley, Arizona. And Curtis Howe from Michigan has checked in. And thanks everybody for showing up. Yeah, so this is RockSim Live. We have, if you've been to our website this week, you know it's been a mess, and it's still a mess, but it's slowly coming back. Let me switch to my desktop. Okay, so this is the Apogee website. Yeah, so if you're going to some product pages, you may not find what you're looking for. Right now, the website is partially up, so people can see it, but we've disabled the shopping cart, so you can't order anything yet. If you want to order, just call us up on the phone. If you go to the home page, my computer's running slow. I don't know if it's my computer or if it's our website. But if you go to the website, here on the left-hand column or the right-hand column, you'll see our phone number, and you can call us there at that phone number, and we can take orders over the phone. It's just not going through the website right now. The reason is we're upgrading the website, kind of like the operating system that runs the website. So the website's not really changing. It's the core operating system underneath that we're upgrading. And it was a massive, massive undertaking. We started the process last year, probably about this time last year. We started getting prepared for today, for this week of the big switchover. Our website, we use a shopping cart that is older, but it has a lot of capability. But it needed to be upgraded so that we could start building in more features and buy us some time to figure out, what we might do in the future, if we're going to stay on this current shopping cart or if we're going to migrate to something different. But in the meantime, we needed it to upgrade so we could build in some new features. And this is kind of where it gets into RockSim Pro, because that's one of the features we want to build into it, is the ability to interact with RockSim Pro, particularly the license keys, because RockSim Pro is different. So it's been a major undertaking, and the website, we took it offline on Wednesday, so we were without a website from Wednesday until just like a couple hours ago. Things started waking up. But now we're finding all the bugs that need to be fixed. And we knew there were going to be bugs. We hoped that it wasn't going to be a lot, but it is what it is, It had to be done, and the only way to find out if you fixed all the bugs is just to deploy it and see what's broken. But in the meantime, give us a call on the phone. We'll be happy to take your order. Right now, with our website being down, it's been really quiet here. We like helping customers, and when the website's down, normally people go to the website and they find all the information and they place their orders online. But with it being down, that didn't happen, and so it's quiet. And we'd like to be able to help you, so call us up. I hope to make those phones ring. I know you need some rocket motors, so go ahead and order those, and we could use the business. Okay, so yeah, I'm afraid to even try doing anything on my website. We'll see what's broken or not. So let me click here on this image, and it's doing something. I see the spinny ball. Oh, look, that page is working. So this is the RockSim Live archive, and this is where we post all the previous episodes. And I'm woefully behind on updating this page, and I don't think it's going to happen anytime soon. But we're on episode 205 today. So we stopped, so I'm like 10 episodes behind already. And we'll get there eventually. But, there's a lot of information here. And here is where you can find what we talked about. And then there's be a timestamp to a YouTube video. So if I open that in a new tab, it would open up YouTube to that video. And it actually opens up to that timestamp. So that works pretty good. So that's what this page is. Let me see if I go to How To and Guides. Come down here to Software. So on this page is where you can get additional information. So here's a RockSim trial. Let's see if it happens if I click on that. Where you can purchase RockSim. Let's click on that. I'm testing the website as we're going along here. I'm opening up a whole bunch of tabs. Frequently asked questions and the system requirements. Let's open that in a new tab. The RockSim video tutorials. Let's open that. So this was the RockSim trial. Ooh, that looks like it worked. Hey, that page is working. So this page where you can sign up for a free trial, although I don't know what happens when you sign up and you put your email in. If nothing happens, give us a call on the phone. We'll be able to help you out manually. So that's the trial. This is the order page. And the order button is not here on this page. So that's not working. Oh, that's the system requirements. I'm sorry. I might have closed that tab. Okay, so here's the tutorials. That page is working. These are like the starting point for RockSim if you've never used it before. This is where you would come. And you click on a video. Like number 1 is getting started by opening an existing simulation or an existing design and then running a simulation. So it's kind of like you stop, slide a rocket motor into it, launch it, and see what it looks like, and get data back. That's kind of like the first thing you want to do is just, okay, can I run a simulation? Okay, good. Now let's start changing things. So that's what these other videos will show you how to do, how to change things, how to design your own if you want to do that, opening existing designs from the Apogee website. Like we got a lot of kits. Let me go to a kit page and see what happens here. Skill level 2 kit. And let's see, the Apogee Aspire. Click on that. Okay, this page is partially loading. That's good. And it's got an add to cart button. That's good. Then there's a RockSim file. If you click here, it'll jump you down to the bottom of the page, and then you can download a free RockSim design file for this rocket. Let's see what happens if I click on it. Oh, look, it downloaded. So that's working. I'm just so happy that the website is up and running at least partially. Because we use it a lot here ourselves. Like while the website was down, you're like, what am I going to be working on? So I was working on a future newsletter. And one of the things I needed to do in the future newsletter was, if you ever read any of our newsletters, let me go to our newsletter. Let me see if that's working. So you go to the home page. And then there will be a scrolling banner bar, and I know that was working. And okay, so here's the sign up for the newsletter. So you click on the banner bar. Let's hope it opens that page. I'm crossing my fingers. Is it working? Newsletter subscribe. Oh yes, it's working. Okay, so this is where you can subscribe to the newsletter. All you do is enter your name and email address, and then you're on our list. And when you get a newsletter, then you would come here. I'll show you what a newsletter looks like. So you go to Peak of Flight newsletter, and then you have this menu here, and this lists the last 3 issues that we've did. But if you want to see all of them, like all 656 of them as of today, you click here on all newsletters, and it will take you to the archive page for all the newsletters. And this is what I needed to get to, so I could see what things I've written about before. So like we have 2 versions. We have a PDF version, which you can download and print out just like a magazine, or we have an HTML, which is good for looking at on your phone because it's interactive. So on these newsletters, you know, when I'm writing a newsletter, I'm often referencing previous newsletters. And this one here, I'm not seeing any. Oh, here we go. Here's some links. Well, there's links to other things. And so I needed to find linking all my articles together so that people can learn. And that's what we do here at Apogee, is we go deep into subjects, and then you can go deeper by clicking on links. And we have to build in those links. And so that's what I was trying to do while the website was down. And I'm making actually pretty good progress on the next newsletters. In fact, next month, as many of you know, is the World Space Modeling Championships in Serbia. So I have to get ready to go to that. And I'm writing all the newsletters ahead of time so that they still come out every week. So you still get something in your email box from Apogee. Once a week is when we send out our newsletters, and we also alternate with a video. So next week will be a video, and then in 2 weeks will be another newsletter. This past week we did a newsletter 656. Was the one I just released this past week, and this one was Martin McKee. He wrote an article on his attempt to launch an Eiffel Tower rocket, like this one right here. This is the actual one. He's actually built 2 versions. This is the big one, and then there's a smaller one that's 80% of this one. And his goal was to launch the Eiffel Tower rocket as high as the Eiffel Tower is in Paris, and what he had to go through to achieve that goal. And so it documents his process, and what we learned from that is basically how to do tests, you know, how to make a test flight program so that you can do something. Not maybe you probably never fly an Eiffel Tower. I don't think anyone will, but you might have a design that you want to do, and you want to reach a certain altitude. So that's what that article was about. And so next week will be a video, and I've already got that one made, and that's part 3 of the series on Ask Me Your Rocketry Questions. And so this is part 3, and I forget what questions. It's been a number of weeks since I filmed it, so I don't remember. Anyway, so that's the Apogee website, and you know how to find information, and it's slowly coming back online. So if you can't place your order online, just give us a call, or I hate to say wait a day, but it's coming back. Anyway, we've got Guppy Guy from Boise, Idaho is in the house, and David H. from Carrollton, Texas. Cool. My daughter is in Texas. She's in Denton, Texas, not too far from Carrollton. Carlos K says, question number 1. Although Rick DeFoss actually has the first question. And Rick DeFoss says, greetings from New Hampshire. Can you show how to add custom parts to the materials database? Okay, so that's an easy one to answer. So let me go to RockSim. Okay, so here's my RockSim. Okay, so let's open a design. So we're going to click on the File Open button up here at the top. And it will give me a file to open. And I'm just going to, this is the Invicta rocket. It's a 2-stage rocket. And you can see that it opened the design, and you can get, down here is the length and the diameter and the fin span on the mass of the rocket. If you want to see it in 3D, you come down here to this button, select that, and it will re-render the rocket in 3D. And this with your mouse, if you have the trackball on, so check that trackball button, and then you can use the mouse to move it around and look at it from any angle that you want. And if you want to zoom in, I'm using the scroll wheel, and I'm just scrolling in to zoom in. And if you want to shift it over to the right or left side, you hit the shift key and then just slide it with your mouse. So I'm left clicking and sliding. Otherwise, you can rotate it around. And you can see it has to re-render. My computer is like really slow. It's getting old. I really need to get a new computer. I still have the Intel chip, and now Apple is on like the M4, which is like 4 newer versions than what I have. So mine is like getting really old. That's why it's slow. Anyway, so we want to add a part to the database, and he says a materials database. Okay, so let's say we've got a new material that we want to make a fin out of, and I don't know what it is. Hollywoodium, the stuff they use in Hollywood. So we're going to make a new material called Hollywoodium. So what you do is you go up here to the rocket menu, come down here to Edit Database, and we're going to go over here to Materials. So this is where we're going to add the new material. Make the spinny ball go away. So here's all the materials that are in the database currently. And let's see if I've used Hollywoodium before. GH, no. So there's no Hollywoodium. Okay, so to add the new material, we're going to click the Add New button right here. And it put a new line on your chart, and right now it's not showing it because it's like here at the very bottom. So if it doesn't show up, scroll either all the way up to the very top or the very bottom. Okay, so here is where you're going to add your new part or your new material. So I'm going to type in Hollywoodium. All right, so now this is a material, and every material has a density. And so what the density is used for, RockSim needs to know the weight of the part we're going to make it out of. So if we make a fin, it needs to know the volume of the fin, and it's going to calculate the volume itself by the dimensions of the fin. So, like a cube is length times width times height. And so RockSim will figure out the volume of the part, and then it needs to multiply it by the density of the material. And when you do that, then you get a mass. So your density units, you can be in kilograms per meter cubed, pounds per foot cubed. You can do centimeters or grams per centimeter cubed. So here are the units you can choose from, and that's all that you can choose from. So you can say grams per centimeter cubed. So this is a volume, grams per centimeter cubed. This is grams per millimeter. So this is like a shock cord. So you're going to take a piece of shot cord, measure a length, and then weigh it. And that's going to give you, you take the weight divided by the length, and that will give you grams per millimeters, or grams per centimeters, or grams per meter. But if it's a item that has volume to it, like a tube or a nose cone, then you need to use pounds per foot cubed, kilograms per meter cubed, or grams per centimeter cubed. It's up to you. So you select that, and then you're going to type in the number right here. So Hollywoodium is a made-up part. So let's say I'm going to use the same one as rubber, so that I can compare and see if it's actually calculating it right. So 1.23, and the units are grams per meter cubed. And I'm going to say fixed dimension. So say none. So then fixed units, I'm going to say millimeters. And you have to select those. Just leave the fixed dimension. So there's a fixed dimension value and then the fixed dimension unit. So they kind of go hand in hand. I've never used these, so just put 0, and then whatever you choose here doesn't matter, because once you got 0 here, whatever units they are, it's still 0. Okay, so then this column here, sometimes they're a checkbox. Like right now here, it's a checkbox. Other times it's a 1. A 1 means that it's been checked off. So can I use this for my rocket? And then you say yes. So why would you not want to use it in your rocket? Well, the easiest way to delete a material from your database is to just go here and check it as uncheck it, and it turns it to a 0. And at that point, you can't use it in your design. So like here, I have titanium, but it's a 0, so it's not going to show up in any lists inside of RockSim. So this is the fast way to turn things on and off. So, but since I want to use it, I'm going to turn it on. Okay, and now you're going to select what kind of components can be made out of this material. So Hollywoodium, I'm not going to use it for a streamer. So I'm going to leave that one as unchecked. A transition section, maybe. A parachute, no. Nose cone, yes. Shock cord, no. Launch lug, maybe. Fin set, yes, definitely. Body tube, yes. Let's see what other columns we have here. We have rings. I'll say yes, yes. Engine block, yes. Sleeve. A sleeve is a tube that goes over the outside of a tube, as opposed to a coupler that goes on the inside. And tube coupler. Okay, so now we have just added Hollywoodium into our parts database, or the materials database. So then we'll click OK. And now let's use this new material. So I'm going to go to the designs, and I want to say, I want to make this fin right here out of Hollywoodium. And I'm going to click on it. And I got the spinny ball. Okay, so it selected that fin. And once it's selected, you can go to Rocket Design Components. Get a sip of water while it's waiting. And you can see it's highlighted one part, and the part that it's highlighted was this. So if you can't find an item in the parts tree, because sometimes, you know, you see this giant list of parts and you don't know what they are. But if you go down here to the rocket and you say, I know that's a fin, and if I click on that fin, it will highlight the fin in just a second. My computer's really slow. Did I tell you that? So it highlighted the fin, and then it will highlight it in the parts tree as well. So then I can go to the parts tree, just double click on it to open it up. And it's still working on it. Come on. Still working on it. My computer's running really slow. This is my computer. It's not RockSim. RockSim is blazing fast. But when my computer, I'm trying to run the live stream and RockSim and YouTube, and it's like running really slow. It's not in the back. It's kind of like hung up. Don't do this to me, RockSim. Because I've just changed it to Hollywoodium. Let's see, do I have to force quit? Let's see if it's running. It says it's running just fine. But it won't let me click on a button. Anyway. I'll quit. Let's see if it'll let me quit. Oh, and then as soon as I quit, then it opened up the fin. No. Let's see if I can hit no. Okay, so, oh, and it quit anyway. All right, let's open it up again. The question is, does it remember that I added a part or a material to the database? Okay, so file, open. I need a design. Victa, open. Okay, rocket design components. Fin set. Let's see, you're gonna open for me. It still wants to be slow. There we go. Okay. So this is the fin. I'm editing that bottom fin. And right now it's made out of material called birch. So if we click on the material and we're looking for Hollywoodium, and it didn't, I don't see it. Oh, there it is at the very bottom, Hollywoodium. And you're not seeing that because you can't see the bottom of my screen. But if I select it, okay, so there it is, Hollywoodium. It did select it. Oh, and I just switched it to aircraft plywood, Hollywoodium. Okay, so when you select that, it will recalculate the mass of the fin. So now it's calculating it at 73.69 grams. And if we choose, I think it was rubber that we had before that I matched the density to. I thought it was rubber. Maybe I'm not allowing to make fins out of rubber. Birch. Let's see what birch is. Just watch the calculated fin set mass. See, it just recalculates it. So, yes, it's working. At least I think it is. And then you can click OK. Yeah, so hopefully that answers your question on how to add a material to the database. I don't know what material you're adding, but that's how you do it. This is like running so slow that it's even making me mad. Carlo says, has anyone emptied an aluminum Michelob ultralight bottle and dreamed of using it as a lightweight fuselage? Well, there you go. You could use make an aluminum rocket. And he says that Michelob ultralight bottle looks like one of my graphite competition models. Cool. And Rick DeFossis says, article 583 has a pretty cool article. What's 583? Let's go find out. I bet it's one that Rick wrote. So we want to go to PicoFlight newsletter, all newsletters, and then we want 583. So we scroll down to 583, motor options for clustered rockets. I think Rick wrote this one. Yes, he did. Our very own Rick DeFossis wrote this article for us. In fact, the newsletter that I was working on was referencing this article. So Rick, you get another thumbs up because I linked to it from a newsletter that's going to come out at the end of this month. I think it's the 26th. So thank you, Rick, for writing this article. Yeah, this was the one. All right, well, that's cool. I got no more questions from people about RockSim. So what's on your mind? Yeah, so what can I show you? Let me open up RockSim Pro. Let's see, is this, I got a new version of RockSim Pro. And I'm still testing out some of the new features. Quit RockSim. Do I want to save my changes? No. RockSim Pro is still launching here. Still bouncing on my screen. I'm trying to figure out what new features we've added since the last release of RockSim Pro. We're working on a lot of stuff. We're working on canted fins and canting them at a specific point in the flight. I think I talked about this maybe an episode or 2 episodes ago. And it wasn't quite working correctly, so we didn't release it yet. And we also added in a feature to calculate the fin flutter velocity, which is important, which is why we don't make fins out of rubber, because they would flutter too much. I just needed to open up doesn't matter what it is. Level 2, 2-stager, Storminator Junior. Let's open that. So calculating fin flutter speed. So this is RockSim Pro. Your RockSim Pro, if you're using it, doesn't have this feature yet. This is something that we're still working on, and I'm still not quite happy with how it works. But there'll be a new fin flutter speed calculator right here, and you can enter an altitude in, let's say, 200 feet. You need, again, like you need to know the density of the material, now you'll also need to know the shear modulus. And then based on that, it will calculate the fin flutter speed. And so based on that fin modulus, if this rocket goes to 312 miles an hour, there's a good chance that the fins might flutter off. I'm just not sure on this user interface. Let me see something. This is like I'm testing things now, and you're watching me test things. So before we went to the materials database, edit database materials, and I want to know, is there a column for the shear modulus? And yes, there is. Okay, so these are the materials that we have shear moduluses for right now. So where do you get a shear modulus? Like, that's the question. So what I would do is go to Google and say shear modulus for balsa wood. What is Young's modulus? We want the shear modulus of balsa wood. And here it is, 0.033 times 10 to the 6th PSI. And so let's check over here and see if we have the same number. Okay, so what was that number? Do we have megapascals as a unit? So this wants PSI. See, that's one thing I need to change, is we can't have everybody convert everything to PSI, because if you go to Google and you want to know the shear modulus, and this says approximately 2310 to 29,900 PSI, and this is a little bit higher. So let's change that. Okay, so we'll go to edit, and we'll say that, what did we say that was 20? I have to pick a number between these. I guess the higher the number, the stiffer it is. So let's go with 29,900. Oops, this one right here. 29,900 PSI. And then click done, and then OK. And then I'll go to the fin set again, or did I have that open already? Nope. And let's change it to balsa. Okay, so look, it did get the new shear modulus, 2,900. Now it calculates the fin flutter speed. It changed it back to feet per second. So now it's to 300 miles per hour. Okay, so now let's make this rocket go faster than 300 miles an hour. Let's click OK. That's at 3,000 feet. Let's see what happens at 300 feet. At 300 feet, it's a lot lower. That's pretty good. Let's use that. Okay, so now we're going to run a simulation. Let's see if I can get it to go really fast. So I need a 24 millimeter motor, and I need the biggest, fastest motor that we have. So I'm going to go to the average thrust in newtons, and I want to pick the one that has the highest average thrust. And there's a Cicerone F240 Vmax. This is velocity max, so this is going to get us as fast as we can go. So I'm going to select that one, and we'll make it a 15-second delay, and click OK. So it loaded the motor, and I just wanted to see how long. So the motor still fits in the rocket, which is good to know. I was worried that Vmax, that's a pretty long motor, if it would still fit in there, but it does. And now we'll just launch it. And let me see what my conditions are here. Max ejection delay. Starting state, we're at an 8-foot long rail, and we're 45 degrees from vertical. Let's go straight up. And flight profile, I'm not sure where we're launching from. We'll see that in just a second, because it will run this. Oops, it's running 100 simulations. I got the uncertainties turned on, so let me cancel out of that. Let's turn off uncertainties. But what happened was we're now at a maximum velocity of 406 miles an hour. So I am sure we exceeded the speed of balsa wood. And it's thinking about doing something. I don't think it liked me canceling the simulation mid-stride. But that's a feature that we're working on, is shear speed, or fin flutter speed. Oh, come on, wake up. It's doing this one too for me. It just next. Guppy Guy is asking a question. He says, are we here next week? And the answer is yes, we should be here next week. I think I am here until I leave to go to Serbia. So, yeah, so I think we're here at least until we leave on August 14th, which is, so whatever the last Friday is before that is when we'll be here. So we should be here next week. And my computer is just like dying. Oh, wait a minute. It did. It did what it's supposed to do. It was supposed to open up the launch visualizer. And rocket, it just blasted off into space. It tells me my altitude, but it doesn't show the fins coming off. That would be cool, wouldn't it? Just they just kind of peel away. Yeah, so this is the launch visualizer, and I'm seeing where I'm launching from. Okay, so this is, I recognize this now. This is the Northern Colorado Rocketry launch site in the Pawnee National Grasslands in northern Colorado. Whoop. And so if I zoom out, you can see there's no cities around there. And then we get the first cities showing up, and I think this is the Denver metro area. No, I think that's Denver. It's huge. So yeah, this is like way north. Yeah, so northern Colorado. Okay, so let me close that. So that did work. But let me go back to the fins. And okay, nothing changed there. Let me go to the simulated. Series changes? No. The simulation summary of that one with the VMAX motor. And let me see, there should be a note here that says the rocket went too fast. No, there's no note. So how would you know your rocket went too fast with that fin material? And so that's why we do these tests. We're trying to make it so that you know, hey, something, this design, it looks like it was a fine flight, but now I've exceeded the speed of balsa wood. Yeah, so we need to fix that, figure that out.
You're not sharing your screen.
I'm not sharing my screen. Oh, I'm sorry about that. I forgot. I don't know how I switched to the main screen. And so you missed all of that. So what did you miss? So what I showed you was under the fin set, we have this new fin flutter calculator here, and you tell it the maximum altitude that you're going to fly to, And it will tell you what the fin flutter speed is. And I'm in miles per hour here. So at this altitude, I can't exceed 292 miles per hour, or there's a good chance the fins will flutter off. And then I ran a simulation, and on the simulation, it looked like a normal flight. It went up and it came down nice. And then I went to the flight simulations, and I came down here and I went into the detailed flight report by double clicking on it. And this tells you a lot more information about the rocket. And what I was looking for in here was a note of some kind saying, hey, my fins fluttered off. And I don't see any. I did have some uncertainties. But this is in RockSim Pro. This is not in RockSim. Let me see something here. What was I just thinking of? Oh, I wanted to turn off my uncertainties. So I had uncertainties turned on because I was working on another newsletter article, and we were going to talk about uncertainties. And uncertainties allow you to change various parameters and run a what do they call it, Monte Carlo simulation, where you have your initial conditions and then you just start varying things. You can vary the direction that you launch the rocket. You can vary the angle. Here I'm varying the coefficient of drag. But if you don't want to vary it, you set it to 0%. So all these are set to 0%. The launch guide elevation angle, if I did 12 degrees, and that's the only thing that I want to change. And then how many simulations I want to, let's just run 10 and see what happens. So you hit launch, and it's going to run 10 simulations in a row. It's still working on number 1. So it finished number 1. It did number 2. And it estimates about 12 more seconds to go, and then it'll be done with the simulation. Okay, so nothing really changed as far as the maximum altitude or anything. But the thing about when you run multiple simulations in RockSim Pro, you can do a plotting graph. And you can do either a RockSim landing chart or a Google Earth landing chart. And so this is a scatter plot, and it tells me just by varying the launch angle where it's landing. So the launch point is the yellow one right here in the middle. The nominal landing point is right here. And it looks like it's really scattered a lot, but in actuality, going from left to right, it doesn't really vary much, but it does vary distance-wise. I had no wind on this simulation. I believe I had no wind. And so launching straight up, it landed right here. And why didn't it land right there? Well, because the Earth is rotating underneath, and RockSim Pro accounts for that. And so it landed just a little, 0.05 feet away. So you can see going left to right, we're not going very far, but because we angled the launch rod and we used a big motor, and the rocket goes really high, you can see it could come down, over, 1,200 feet this direction, and 1,000 feet in that direction. And if you click on these points, it will tell you what had to happen to get to that point. And so if I would have launched at an elevation of 15.82 degrees from vertical, that is the point I would land at. And if I clicked over here, this one is a minus 6.11 degrees. So it's the launch rod is angled in the other direction. Like I said, this is like a Monte Carlo simulation. So you don't get to pick the numbers, but you get to kind of pick the range, and it just randomly picks numbers in there, and it runs the simulations. And I only ran 10 simulations, so there should be 9 blue dots and 1 red dot to show the simulations. Or maybe it's, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got the nominal condition and then 10 uncertainty conditions. And you can also, if you want, let's see if this works. I need to launch Google Earth. You can also see the simulation in Google Earth, all those plots. So it should be like the launch visualizer, but instead of being inside of RockSim, it will be in Google Earth. And Google Earth, you can download that from the internet. That's free. Okay, so again, that looks like very much like what we saw before. Why you won't let me click on these? Okay, turn them on. And why am I not seeing these? Yeah, okay. Here's the nominal launch. Am I in the wrong location? I am in the wrong location. So there it is, right there. So that's the uncertainty point number 3. And if I click on it, it brings up that same information. So it shows the error of 14.35 degrees off. Let me zoom out. Yeah, so this is the launch point, and that's the nominal landing point. The nominal landing point is, like I said, it's 0.05 feet away from the launch pad. So it goes straight up, straight down because there was no wind. But once you start angling it, and this was the direction that I had it angled. So it's like right along this road right here, which is kind of interesting. Ron's Rocket says, by the way, I finally purchased RockSim, so you can now increase the price. Cool. Thanks for your permission. Ron says, a friend tried to purchase decals from Apogee, but had to be shipped via box instead of a cardboard envelope, increasing the shipping charge. Is there a reason for that? Is there a reason why envelopes are not a shipping option? And that is a very good question. Don't save. The reason why, no, I'm going to go back to my desktop. So outro. Okay. The reason why is because of our old website framework. You know, the one that we just updated. One of the problems is on our website, we have what's called a shipping module. And the shipping module, when you order items, it gathers them all up. And in the database, there's dimensions, length, width, and height of every item. And then it uses that, and then it tries to figure out what size package it should go into. And right now, because of the old system, it's limited to just boxes, not envelopes. And that's why we couldn't give you a price with an envelope. The only way to get the price with the envelope is to give us a call on the phone, because then we can do it manually. But the website, it wants to automate everything. And that's what we want. That's what people want, is they want everything automated. You know, they don't want to have to pick up the phone and call us. So we tried to build that into the website, but Sometimes you can't build in everything you want, and then sometimes the infrastructure underneath the website is so old that you can't add those features. And so this was one of the big reasons why I wanted the website updated to the new base OS system underneath. Because now with the new system, maybe, I'm not sure if we're going to be able to allow envelopes or not, but maybe we can build in envelopes as well to get the shipping costs down. I know there's other ways that if we can upgrade our website, we can get a better handle on shipping fees. The way we handle shipping, for those of you that know us, is the website will estimate something. It will charge your card based on that estimation. But when we actually go to ship it, we get a price from the post office telling us exactly how much it costs to put it in that package. And then if you've been overcharged, we refund the money back. Our goal is not to make any money on shipping, because we know nobody wants to overpay for shipping. So, right now we have to automate things, we have to overcharge, but then we refund you back. What we hope in the future is that we won't have to refund you back. It will be able to calculate a better shipping cost based on what size package it's going into. And maybe we can do envelopes. But normally it's only things like decals that would go into an envelope. Not much of what we sell is that thin anymore. And here's the thing, even a centering ring, like a little tiny centering ring, the post office says that if your package has any thickness to it, it can't go into an envelope. So you can't stuff, like a single cardboard centering ring into an envelope. Sometimes it will get through the system, but a lot of times it gets flagged because the post office has all this automated equipment to process mail, and they have different equipment for packages than envelopes. And so if an envelope with something thick tries to go through the machine, it's going to jam the machine and potentially, break the machine. And then the post office gets really mad, and then they go after the person that shipped the item. And so we don't want the post office coming after us because we can't afford to pay for their equipment. So we follow the postal rules, and the postal rule says if it's got thickness to it, it's got to go into a box. And I know people don't like it, but it's just the way they process packages. Shipping is a nightmare. I wish there was something better. David H says, does wind range affect the flight simulation for drift based on the version of RockSim? It does. Wind does affect the drift of the rocket, but no, it does not depend on the version of RockSim. All versions of RockSim use the same algorithm for calculating wind drift. So you don't have to worry about that. If so, I could not make it do so. No, yeah, so you're going to get wind, and I'm in RockSim Pro. RockSim Pro does wind different from regular RockSim. In RockSim Pro, there's a wind table. And so you can have different wind at different elevations in the sky, and you're not seeing my screen. So you can have different wind levels at different altitudes. Not only that, you can have different directions. So the wind at this altitude might be this way, where the wind at a lower altitude is going this way. So you have a wind shear. And you got to remember, you got to look at the units. And so this is ASL, so that's above sea level. So at sea level, I can have a wind direction of 260 degrees, and I can have a velocity of 10 miles an hour. And then at 80,000 feet above sea level, I can have a wind direction of 180. So 180 is coming out of the south. 260 is, or 270 would be from the west. And these are compass directions. So 0 degrees is north, 90 is east, and that's the direction the wind is originating from. So it's coming from the east, blowing to the west. This wind at 270 is coming from the west, blowing towards the east, and it's blowing at 10 miles an hour. And we'll make this one 20 miles an hour. Make sure my uncertainties are turned off here. Make 0 uncertainties. And let's change it to a different motor. Let's make it an F, that one. And hit flight profile. And when this is done running, okay, so it always opens up the launch visualizer. Okay, so the rocket's sitting on the pad. Let me turn off the weathercocking cone. Okay, so here's the rocket sitting on the pad in the middle of the road. And when we launch it, it goes up in the air. You can see the wind is affecting it. It's making the rocket tilt into the wind. And we're just about at Apogee. That's Apogee point, and the rocket's coming down. It's coming down really fast. Okay, so now the parachute popped out, and it's drifting down. And it's going to take a little while, so I'm going to speed things up and make it go all the way down to the ground. Okay, so now we want to see the whole trajectory, so I'm going to zoom out. Okay, so that's the trajectory. Okay, so I'm going to swing north out to the top. So the black arrow down here on this compass wheel is north. Just trying to spin things around so that black arrow is in the top. Okay, close enough. Okay, so now if we look at it from up above, whoop, I went too far. I should just hit the 2D button and it'll look straight down. Okay, so now we're looking straight down on the rocket. So the launch pad was right on the road, and it arced to the west, and then it came back down towards the east. But remember, our wind was set up from sea level, and this elevation here, we're in Colorado, so we're well over 5,000 feet above sea level. So if I wanted to make it noticeable, I would rerun a new simulation, and I'll change the, I want to see my altitude. We're currently at 1,600 feet. So my wind table, my new altitude is 1,600 feet, and it's going to be at 10 miles an hour. And let's make it, how high did this rocket go? 1,800 feet. So let's make it at 1,000 feet. It's going to be coming out of the 180 direction. It's 1,000 feet above the 1,600, so I got to make this 2,600 feet because this is above sea level. And then we hit flight profile. So now it's exactly 1,000 feet above ground level. We'll have a different direction. And yeah, we're still hitting 1,800 feet. Okay, I'm going to go all the way down, back down to the ground. I want to look at it in 2D. I want to zoom out. Okay, so now this is a different trajectory. So the launch point is right there where my cursor is, right in the middle of the road. And the rocket goes up. Here's the apogee point. Once the parachute deploys, you can see it's not a straight line. This red line right here is the ground track. And this is curved because we have a wind, an upper elevation going this direction and a lower elevation going this direction. And so as it comes down, the wind is shifting around. And so we're getting a different wind direction, a different trajectory as it finally touches down. So that's kind of what it looks like coming down. Okay. So hopefully, David H., I hope that helps you out. It's going to be different in RockSim because we set up wind a little different. We can't have different wind directions at different altitudes. All in RockSim, it's just one constant wind, no matter how high you are. In real life, you get multiple winds and you get wind shear. So that's what we try to do in RockSim Pro so that it's more realistic. Lots of fun. So, yeah. Thanks you for watching. We will be back next week. I don't see why we shouldn't be. I'll be out of town for my daughter's diving competition, but I'll be back before Friday. So, yeah. So we'll see you next week, and I'll give you a countdown, and we'll get out of here. So in 5, 4, 3, 2, 1, go out and launch something.